Okay, so now we start. So how are you today? Are you doing well? Okay. Okay. So anyone read the newspaper or no newspaper? Not listen to the news today? Not yet. So this morning, the monthly, the CPI, the Consumer Price Index, has been released. So do you know what's the inflation rate in the United States in December 2021? Consumer inflation rate. Maybe you can guess how much the price has been increased in the last year. Annual rate.
20%.
20%? Mm-hmm. Anyone else?
Isn't it like 5%?
5%? Okay. And anyone else? Maybe I will give the small credits for the answer, which is closest.
10%?
So 20. Sorry?
10%?
10%? I see. Anyone else? Maybe up to 4 answers, 25, 10, and anyone else? Anyone else? Okay, so just this is a free opportunity to get some bonus credits. So anyone else? The Bradley? Bradley, what's your guess?
8%.
8%. Okay, so now that we see the Bureau of Labor Statistics website to see what's the actual percentage. Okay, so the CPI, the Consumer Price Index, is released by the US Bureau of Labor Statistics. This place also hires the statisticians and economists. And this is the page. Then you can see that, for example, the energy, the gas price and fuel price, that increased by 30%, but the food more moderate, like 7%, and the item excluding the food and energy, it's the 7%, and the total is what you can see in the release. And actually, it's the 7% increase over time. And actually, if we exclude the food and the energy, it's 5.5. But actually it's 7%. So maybe the Bradley, they got the closest answer. Okay. Yeah, so that means that, for example, that we are studying interest rate. Interest rate is currently almost 0, between 0 and 0.25%, because it fluctuates. But the inflation rate is 7%. So in real basis, the inflation rate is like negative 6.75%. So if you keep just money in a bank, then maybe it will earn the interest between 0 to 0.25%, suppose. Then the price goes up by 7%. So the real interest rate is 6.75%. That is all often overlooked by the market, even the financial market. So people care about the nominal interest rate. And that is usual interest rate, but the real interest rate, the inflation rate, also has to be considered. Yeah, so this is monthly rate. So in December, only for 1 month, the price increased by 0.5%. So you can see it's a very large increase. And compared to this inflation rate, the change in interest rate, it may increase maybe by 1% this year, but that is very small compared to the inflation rate recently. it's a very special situation, and the inflation reached the 7% the last time in 1982. That is just after the second oil shock. Yeah, inflation rate also will be discussed in later in this textbook. Okay, so now the review of the last lecture, just briefly. So last time that we studied several interest rate. So one is simple interest rate, that is just a linear function. I mean the x plus b. And the another one is the compound interest rate. That means the interest also earns the future interest. Yeah, and the last time we defined the accumulation function, the lowercase a of t. So lowercase a of t is the amount at time t. And for standardization purpose, that we define the a of naught is equal to 1, a of 0 is equal to 1. So if the $1 becomes, for example, the $1.75 in 3 years, then the a of 3 is 1.75. And the next one, the amount function, capital AT. So this is the same as the lowercase a of t, but the capital A of 0 is not necessarily 1. So it can be used to represent the account balance of your bank account. So maybe initially you have $200. Then if it increased by 75%, then that becomes $350 in 3 years. So A of 3 is 350. And present value and accumulated value, if the start point and end point are clear, then PV means the capital A of 0, and the AV, accumulated value, means the capital A of t. And the effective rate of interest is the A of t minus A of t minus 1 over A of t minus 1. So if $100 becomes 105, then 105 minus 100 over 100. So the effective interest rate is 5% or 0.05. Lowercase a and capital A only differs by a constant k. So I mean constant times A of t is capital A of t. So that we can do the same argument for the capital A. Yeah. And some examples, and a simple interest means that this function, so it's the first degree polynomial of t. And the compound interest means the A of t is 1 plus I to the power t, where I is the effective rate of interest. Okay, so now that we start today's lecture, and before that, we will have a quiz on Wednesday next week. Usually we have quizzes on Monday, but the next week, the Monday is the MLK day. So we have quiz on Wednesday. I will post homework today after the lecture. Do you have any questions about the last lecture, or if you have any trouble in the online quiz? You can ask questions. Okay, so now that we start the lecture, so we introduced the other notations today, the V and D. Yeah, so basically that's a function of interest I, but sometimes we use the other notations. And the one common notation is V. V is defined by 1 over 1 plus I. So this actually assumes that the effective interest rate I is constant. So assuming effective interest I is constant, generate the changes over time. But if it's constant, we say V is we define v as 1 over 1 plus I. So we don't have any name for v, but the v may be called a discount factor because this means the v becomes, the v dollars becomes $1 after a year, right? Because after a year, basically we have to multiply 1 plus I. So v times 1 plus I becomes 1. So the v is actually the value of $1 1 year before. So the v may be called a discount factor. This may not be the formal name. V appears everywhere in the textbook, but it does not have a name. So for example, if I is 5%, then the V is equal to 1 over 1 plus 0.05. So that is about 0.9524. So, 0.95 becomes a little less than $1, right? So $1 becomes $1.05 after a year. So yeah, so this means the 95.21 cent becomes $1 after a year. Okay. And if I is positive, usually I is positive. If I is positive, then the V is equal to, the V is less than 1. If interest rate is negative, then V is less than 1. So negative interest rate, it's very uncommon, but it's used in several places. Now, do you know which countries have negative interest rate?
Pakistan, I think.
Sorry?
I think Pakistan and the Middle East, maybe.
Oh, okay. Actually, now the negative interest rate is pretty common in Europe. The EU and Japan, and also the Switzerland and some Scandinavian countries. And as far as I know, the Switzerland they introduced the negative interest rate many years ago, decades ago. I heard from my father, the Switzerland has the special, financial regulations that is pretty, friendly to, investors. So basically the old people invest in the Switzerland. So to avoid to attract more money and to avoid the too expensive currency that Switzerland sets the negative interest rate. It sounds strange, but basically negative interest rate means the money depreciates. So $100 becomes $99.50 after a year. So no one deposits money into the bank, but it's possible if that cost is less than the cost to keep money. So if you have, for example, $1 million, you cannot just put it in your room. So it's so risky, right? So it needs some cost to maintain. So slightly negative interest rate is still possible. Okay, so the example 2, if the effective interest rate is I every year and the capital A of T is equal to 1, then what's the present value? So we think about, time diagram. So this is often used in actuarial mathematics. So we have the time 0, 1, 2, and T. T may not be an integer, any number. Okay, then $1 here. So capital A of t is 1, then what's the present value? Present value is here. So present value, so that is A of 0. Okay. So maybe I need a little more space, so I put here. Okay. A of 0, and that is actually v to the power t, right? Because the 1 year we accumulate interest of I, so every year that we have to multiply 1 plus I. So in the simplest case, if t is an integer, then we have to multiply 1 plus I t times to get $1. So that means the A of naught, A of 0 is the 1 plus I to the power negative t. Yeah, so this is equal to the v to the power t. So 1 becomes the v to the power t, the t years before. So often we compare the amount at specific time point. So we cannot compare the $1 today and $1.50 the 5 years later. Okay, so if the time points are different, then the value of the money is different. So we have to use some certain point to evaluate all the money or all cash flow. So it's convenient that the 1 just becomes v to the power t. It's slightly simpler than 1 plus I to the power negative t. Do you have any questions? Okay, so now the more non-trivial example. So suppose that the effective interest rate is 10%. So that means in our notation, I is equal to 0.1. So how much deposit is required today to get payments of $100 at 2 years from now and $200 at 3 years from now? Maybe this sentence should be how much deposit is required at least. To get payments of $100 in 2 years and $200 in 3 years. Okay, so can you guess the answer? So at first, so the deposit required today is more than $300 or less than $300?
Less than 100.
Yeah, so less than 300 because it accumulates interest. So we don't need $300 today, right? So what's your guess? Maybe the first 4 people to answer the question.
$25.
Sorry, the 25?
25. I
Okay.
think.
But you need $300 payoff in total, right? Anyway, okay, so any others?
Oh, 200, 250-ish, 230, I guess.
230? Anyone else?
Yeah.
Let's say around 80.
80?
Yeah.
Okay. The last one? Anyone?
150.
150? Okay, so to think about this, the interest rate is 10%. So so I also make a guess. $100 in 2 years, but the 2 years ago we have 20% less, roughly $80 maybe. Plus we need this $200 in 3 years, but we need 30% less. So maybe a little more than $140. 10% of $200 is $20 and times 3, $60. So 140, but plus something. Because the $80 becomes 100, but the 20% discount of $100 is $80, but the $80 plus 20% interest is only $96. So we need a little more. So my best guess is like 230. So I guess this is the best answer. Who said 230? Sorry.
That was me.
What's your name? Sorry.
Isam.
Isam, okay. So at this point, the Isam is the closest answer. Got the closest answer, but okay. So now that we calculate it accurately, but the make a guess is always good. Even actuarial exam, sometimes actually the FM exam is multiple choice. So if the answers are all answers are not close each other, then just making a guess, they can get the correct answer. Okay, so time diagram again. So this is year, and you get $100 in 2 years and $200 in 3 years. Then $100 is worth 100 times the V square at time 0, and $200 is worth 200 times the V
cubed.
Right. So the present value is the summation of this. Okay, so and at first we want to calculate V. So V is equal to 1 over 1 plus 0.1. So this is 0.9091 or something like that. Right. And then then we calculate it. So the PV is equal to 100 times V cubed, V square, and 200 times V cubed. So this is what the 82.64 plus 150.26. So this is 232.90. Okay, so $232.90. Yeah, so it's much less than $300. But current interest rate is 0.25, less than 0.25%. So it's not really similar to this situation. Okay, any questions? So one question about this. So the quiz 110.4 is about this lecture, this example, similar to this example. Okay, so now that we go on to the next one. So that we have another notation, D or D sub T. So the effective rate of discount at time T is defined by AT minus 1 over AT. So this is similar to the definition of I sub T, but you can see that this part is not A of T minus 1, but this is A of T. So usually the starting point is T minus 1. So the denominator is A of T minus 1, but the discount, the rate of discount that uses A of T. So yeah, so this is the definition of the effective rate of discount. And this means that the 1 minus D sub T dollar becomes $1 after a year. So IT, the I sub T, the $1 becomes 1 plus I sub T. The 1 becomes 1 plus I sub T, but here, the 1 minus D sub T becomes the $1. Okay, so that is the difference between D and T. So the in short, the DT is slightly smaller than IT usually. Okay, and yep. So okay, so but this is for the borrowing interest. So if this is fixed, then we can simplify this. So if I sub t is equal to I, for all t, then d becomes I over 1 plus I. So you can see it's slightly less than I, because 1 plus I is a little larger than 1. So this is because d is equal to, you can calculate it. So d is equal to a sub t minus a sub t minus 1 divided by a sub t. And this is equal to I times a sub t minus 1 over a sub t, right? Because the a sub t becomes a sub t minus 1. So this place, the changes to a sub t minus 1 for I. So if we multiply the a sub t minus 1 and divide by a sub t, then this becomes t d. So then what is this? So actually this one, so the inverse of this is equal to 1 plus I. Right? So that means, okay, so this is the 1 plus I inverse. So this becomes I over 1 plus I. Yeah, so D is larger than I if, and this is smaller than I. Is smaller than I if the I is positive. I is negative, it's a different story. Yeah, so the numerical example. So if I is equal to 8%, then D is equal to 8% divided by 1 plus 0.08. So this is about 0.0741. So that means, yeah, 1 minus 0.0741 becomes $1 after a year. And also the V and the D is related. So the V is equal to 1 over 1 plus I. And this is equal to the 1 over 1.08. And this is actually 1 minus D. So yeah, it's clear because the D becomes 1. Sorry, 1 minus, sorry. The 1 minus D dollars becomes $1 after a year. And also V becomes $1 after a year. So 1 minus D is equal to V. So the fact is that the V plus D is equal to 1. Yep. And a D is less common in actuarial exam. So usually we use only I and V. But sometimes the question is asked as D. So D is also common in some places. For example, the zero coupon bond uses this kind of concept. So a bond which mature in 1 year and the payoff is $1. Then what's the today's price? And that is actually D dollar. So the D is used for the zero coupon bond, for example. Okay. Yeah. So the next example is similar to the last example, the 2 slides ago, but it uses the rate of discount. So you borrow X dollar today and pay off the debt by repaying $1,000 a year for 3 years. So 3 payments of $1,000 each. The first payment is a year from now. Yeah. So the effective rate of discount is 6%. So D is equal to 6. Okay. 0.06, I mean. Yep. So determine X. So, okay, so let's have a time diagram. Okay, so 0, 1, 2, 3. Usually we use year. And we have the repayment of $1,000 here, and $1,000 here, and $1,000 here. And you borrowed the X dollars today, and the X is here. So what's X? So can you guess the answer? Okay, so the first 4 people to answer.
I think what I would do first is equate the 1,000 to d, 1,000 there to d squared, 1,000 to d cubed. Add them up, d plus d squared plus d cubed. I think it's probably going to be about $200.
200?
No, let me change that. 750.
So 700? What?
750.
750? Okay. So you need the $3,000 payoff in total, but today's value is certainly the less than $3,000. Okay, so what other answers?
Probably about 2,500.
2,500?
I'll say like 2,750 then.
2,750?
2,600.
26? Yeah, it's a little bit hard, I guess, but yeah, I think that your answers are really, I think it makes more sense than the last ones. And yeah, so okay, so I will guess. And $1,000, for example, this one, and the approximately 6% discount every year. So this 1,000 should have the $60 discount. So next $1,000 has 2 years of $60 discount. So approximately 120 discount, and this approximately 180 discount. So my guess is 3,000 minus the total of this. So this is 360. So maybe 2,640. So 2,600, maybe 2,750. Probably these are the possible answers. Okay. So probably 200. Yeah, not sure. So we can try. We can calculate it, and we can see how much we have. Okay, so X is, okay, so how to calculate it. So this 1,000 is worth the 1,000 V, and this 1,000 is worth 1,000 the V square, and the last one is 1,000 V cube. Okay, so yeah, so, and at first we have to calculate V. So V is equal to 1 minus D. So this is 0.94. So in some sense, it's easier to convert compared to I to V. And X is equal to 1,000 V plus 1,000 V square plus 1,000 V cube. So this is, there are several ways to calculate it. So 1,000 times V plus V square plus V cube, and you're, math students, so you can maybe skip some steps, only 3 times, but for example, you can do this, right? The V cube and the V are less than 1. So in this way, every factor is positive. And this becomes what? This becomes the 1,000 times V. V is 0.94, and times the 1 minus the 0.94 cube minus 1 over 1 minus 0.94. So this becomes 2,654.
18 cents.
18, yes, yeah, thank you. And this, okay, so what's the closest? The 2,600 is actually closest. Sorry, who said the 2,600?
That was me.
What's your name?
Garrett.
Garrett. Garrett Quality.
Garrett Clay.
Okay. Thank you. Okay, so I will add the small credits to your quiz score. Okay. Yeah. So, do you have any questions about this? So certainly, this kind of transformation is useful if we have the more than 3. If we have 10 or 100 the payments, then certainly this is a good shortcut to calculate it. If we only have 3, then you can calculate v square and v cube individually. Okay, so next one. Oh, actually, the similar quiz, example, a similar example to this in the quiz 1.12.1. Okay, so the next one, yep. So next, we use the compound interest. So usually the interest compounds. For example, in the bond market, what's the the period for compounding? Do you know? Does anyone have a bond, government bond? No, maybe no. So the interest accumulates every half year, so semi-annual. So that is the bond market. But sometimes it's shorter, sometimes it's longer. And the nominal, for example, a nominal interest of I compounded quarterly means that the interest compound 4 times a year. So that means every quarter you earn the 1/4 of I as interest. So 1 plus I over 4. So for 1 year, 4 times of this. So the 1 plus I over 4. So we multiply this 4 times. So if for t years, what happens? That becomes the 4t times. So 1 plus I over 4 to the power 4t. So that is the accumulation function of the nominal interest rate of I compounded quarterly. Yeah, so particularly for 1 year, the A of 1 is equal to the 1 plus the I over 4 to the 4th power. And this is larger or smaller or equal to 1 plus I. What do you think? Larger, equal, smaller?
I'm gonna say it is smaller.
Smaller? You mean left-hand side is smaller?
No, I changed my mind. Greater.
Greater. How about others?
I would say greater as well.
Yeah, it's greater because the interest also earns interest. So suppose interest rate is 10%. If you get you deposit the $10,000, then if you get $250 after a quarter, then that $250 also earns interest later. So it accumulates interest more. So that means it's greater. Okay, so but we need a condition that the I is positive, right? So if I is negative, then maybe the story is different. So the perfect answer maybe it depends on the sign of I. And this 4 can be changed for the compounding interest. So when quarterly, we say M is equal to 4. And if 4 is replaced by M, then M is equal to 2 means the semi-annually, and M is equal to 12. It becomes monthly compounding, and M is equal to 365 daily. maybe it's a little bit different if we have a the February 29th. Yeah, but we can define this in the same way. Okay, so for example, what is the annual effective interest rate, effective rate of interest if the nominal interest of 12% compounded quarterly? So that means the 3% quarterly, right? So the nominal rate of 12% compounded quarterly. So this is the very special sentence only in actuarial math, but the quarterly a nominal rate of 12%. 12% is annual rate. So quarterly, we divide by 4. So this means 3% quarterly. So effective interest rate should exceed 12%, and how much it will exceed. 1 plus I is effective rate. This is for 1 year. So that is 1 plus 12% over 4 to the 4th power. And this becomes 1.03 to the 4th power. So this is equal to 1.1255. So actually, the I is equal to
12.55, 0.1255, and 12.55%.
Yeah, 12.55%, yes. So it's 0.555% larger than 12%. Okay, so this notation is a little bit complicated. So we define I superscript M, maybe superscript parenthesis M. This is defined by an equation 1 plus I superscript M over M to the power M. Sorry. This is equal to 1 plus I. So this is similar argument to the last one. So effective interest rate is I. And the corresponding kind of quarterly rate, if M is equal to 4, is I superscript M. Okay. So for example, to get, for example, to get maybe 9% annual effective interest, we don't need 9% rate if it compounds quarterly, right? So we can have slightly smaller number to achieve 9% effective rate. And that is I superscript M. So the image is that if I is 10%, then I superscript, for example, maybe 4 or maybe monthly 12, 4. This is slightly smaller than 10%, maybe 9.6% or something like that. So it compounds. So slightly smaller rate is fine. Yeah. So we don't have a name again, but this can be said as the nominal annual rate compounded M times a year for the annual interest rate I. Maybe annual effective interest rate I, maybe. Yeah. But the idea is that to achieve 10% interest, if it compounds, the interest rate nominal rate can be smaller. Or if you want to define I superscript M as just a function of I, then, okay, so you can take the 1 over M's power of both sides. Then after that, we move this 1 and we multiply by M. So this is M times 1 plus I to the power 1 over M minus 1. So we can calculate in this way. So determine I superscript 12 when I is equal to 9% and also I is equal to 3%. So I superscript 12 is slightly smaller than 9% for this case and slightly smaller than 3% for this case. So 1 plus 0.09 superscript 12 over 12 to the power 12 should be equal to 1 plus 0.09 for this case. So this means that the 0.09 superscript 12 is equal to, maybe by this equation, 12 times 1.09 to the 1/12 power minus 1. So this is equal to 0.0865. So this is equal to 8.65%. And in the same way, the 3%, 1 plus 0.0312 over 12 to the power 12. Sorry, the terrible writing. And this should be equal to 1.03. So 0.03 superscript 12 is equal to 12 times 1.03 to the power 1 over 12 minus 1. So this is equal to 0.0296. So 2.96%. Okay. And you can see that for 9%, this becomes 8.65. So difference is 0.35%. And here, the 3%, we have 2.97. So difference is only 0.04%. Nine minus 0.35. And so this one, so 0.35 is much larger than 0.04. So higher interest, the more effects of compounding. So that's natural. The snowball effects. So yeah, so the smaller percentage, it does not change much. So one reason that the actuarial exam has the higher interest rate in the questions, because if lower, everything becomes very similar. So as an exam question, maybe it's not appropriate because the rounding becomes more crucial and it becomes a little harder to deal with. Okay, so yeah, and one question similar to this in quiz 112.3. Oh, what's time? Okay, so still more. Okay, do you have any questions? This notation is a little bit complicated and it does not appear in the exam too often because we have some ways to escape from this, but certainly it makes some sense. For example, I have a bank account which pays 3% interest, but actually the 3% is annual effective interest rate. Actually the APR or APY, so this is actually the annual effective interest rate. APY or APR is used in many places in the advertisement of financial institutions. And this means annual effective rate. So actually my bank account have 3% interest, but that is APY. So that means, and it compounds monthly. So actual rate is 2.96%. I mean, actual nominal rate compounded monthly is 2.96%. Okay, so do you have any questions so far? Okay, next one. example, so if the nominal annual rate is 7% and the interest is compounded every 2 years, then what is the annual effective rate? So this is a little tricky question. So it compounds every 2 years. So that means that means the $1 becomes $1.14 in 2 years. Okay. So $1 does not become $1.07 after a year, but rather you have to wait for 2 years to get interest. So what is the annual effective interest rate? I. Okay, this is I. Then after 2 years, it becomes the $1.14. So 1 plus the 0.7 times 2. So this should be 1 plus I square, because annual effective rate is I. So after 2 years, that becomes $1 becomes the 1 plus I square dollars. So this means that the I is equal to 1.14 to the half power minus 1. So this is equal to 0.0677. So 6.77% approximately. So this is one answer. So this is sufficient. If you really like the notation of I superscript, then we can say that the 7% is equal to I superscript 1/2. So quarterly compounded interest, that we use the I superscript 4. Quarterly means the 4 times a year. Every 2 years means the half time a year. So the I superscript 1/2 makes sense. So in this way, we can say that the 1 plus I superscript 1/2 this is, yeah, so this is equal to annual effective rate 1 plus I, sorry, we have to multiply 1/2. So this becomes the 1 plus I. So you can say that if you solve this, then 1 plus 0.07 over 1/2 to the power 1/2 is equal to 1 plus I. So I is equal to, you can say that the 1 plus the 0. Yeah. So you can say that this is 0.07 over 1/2 is 0.14. So 1.14 to the half power minus 1. This is equal to, yeah, it should be the same, 0.0677. I think this is overly complicated, but still we can get the same conclusion. Yeah. Any questions so far? Yeah, actually the solution 1 is sufficient for this case, and mostly we can avoid this notation I superscript m, especially m is less than 1. It's too complicated. Okay, so next definition of the d superscript m. So this is the discount version of the compound interest. And the d superscript m, the definition is the 1 minus d superscript m over m to the power m is equal to 1 minus d. So interest compounds m times a year. Then d superscript m achieves the annual effective discount rate of d. And also if I is positive, then D superscript M is smaller than D. So it's similar to I superscript M. So we don't have a name again, but this can be called as the nominal annual rate of discount compounded M times a year. So this means the 1 minus the D superscript M over M dollar becomes $1 after 1 over M years. One over M year, maybe. Anyway. Yeah, and also, okay, so it's a little bit complicated, but we consider the relationship between I superscript M and D superscript M. That should be simple because the both have the compound interest. It compounds M times a year. So, okay, so 1 minus D superscript M over M to the power M. This is equal to 1 minus D. So this is the definition of this superscript M. And this is equal to V. Remember that the D plus V is equal to 1. And this is the 1 plus I inverse, right? So the V is equal to 1 over 1 plus I. And 1 plus I is equal to 1 plus the I superscript M. Sorry. Over M and to the power negative M. So 1 plus I is equal to 1 plus I superscript M over M to the power M. So this is inverse, so that we put the negative sign here. So that means 1 minus D superscript M over M is equal to 1 over 1 plus I superscript M over M. Yeah. So you can see the relationship between this superscript M and I superscript M. Okay, so example, the nominal rate of discount is 9% compounded monthly. So that means the D superscript monthly, so 12. So this is equal to 9%. Okay, so if the accumulated value is $2,000 at 3 years from now, then what is PV? So T is equal to 0 to 3. Okay, and PV, what is PV? PV is accumulated value times 1 minus D to the power 3. So 1 minus D is equal to V. So AV times the V to the third power, and this is 1 minus D cube. And then accumulated value times, okay, so this is 1 minus D is equal to 1 minus the D 12 over 12 to the 12th power, okay, then this cube. So this becomes 2,000 times. Okay, so D superscript 12, that is 0.09, and the divided by 12, so that is the 0.0075. So then 1 minus, so 0.9925 to the 36th power. So this is equal to $15252. That's strange. I think the 1525.2. Right. So AV is 2000. So I think that this is this. Right? Yeah. So this is the present value. So do you have any questions? So often the D superscript M, I superscript M, and also D can be given in the problem, but you can always transform this into simpler terms using I and V. So that's often the case. So there is one question, the question quiz 112.4, similar to this. Okay, so if you don't have question, we have a kind of new concept, the force of interest. The force of interest is continuous version of interest rate. So interest accumulates, interest compounds quarterly or monthly or daily. But basically, mathematically speaking, we are thinking about the rate of change. So it's natural to think about continuous version of interest. So the interest rate, they may not be constant over time. So we want to define the momentary interest rate. So, okay, so think about accumulation function again. And here is t, and here is a of t. And it starts with 1. And accumulation function is like this. And at t sub 0, at any point, basically we want to define interest rate as just the tangent at this point. I don't know, like this tangent line. So we want to make this slope as the momentary interest rate. Okay, so definition of force of interest, momentary interest, delta sub t is equal to ddt of a of t. So the slope. But always interest rate is based on the amount you have, right? So we divide this by a sub t. Or you can say that the interest rate was the a sub interest rate for t plus 1 year. The t plus first year is the a sub t minus 1, t plus 1 minus a sub t over a sub t. So this was the interest rate definition of I sub t plus 1. But the momentary interest rate, so basically we want to make this 1 into small number like epsilon. So in such a case that you take the derivative here, then the divide by at. So if you use the usual prime symbol for derivative, that is a prime of t over a sub t. And of course, this is equal to the d, also using the capital AT. You can write in this way. So this is the force of interest. Okay, example. So suppose that the a sub t is equal to 1 plus 0.2 t. So simple interest, 20% simple interest. Okay, so then they calculate the delta 1. So simple interest of 20%. Delta 1 is larger or equal to or smaller than 20%. What do you think? Hey,
Smaller.
sorry, smaller?
It's gonna be smaller than
Smaller, okay. Anyone else? So what's the reason that it's smaller?
When you take the derivative, you lose the t, so it's just going to be 1 over 1 plus 0.2 t.
Yeah, that's true. Yeah, that's true. And yeah, so simple interest is effectively the less than the nominal rate, right? So 20%. The first year it's fine, but after that, it effectively becomes smaller because interest does not earn interest. So delta 1 is equal to the a prime of 1 over a1. So a prime of 1 is 0.2 and a of 1 is equal to 1 plus 0.2 times 1. So this is equal to 0.167. So maybe. So this is equal to 16.67%. So it has already earned the 20% interest for the first year. So 0.2 over 1.2. So it's smaller. So this is the effective, this is the force of interest. And you can calculate this for any time point, such as t is equal to 1/2 or t is equal to 0.7 or so on. Yeah, so using this, then actually even if the rate changes continuously, still that we can represent a of t as a function of delta t. And a of t is actually equal to exponential of 0 to t delta sub r dr. Yeah, so proof. So delta sub t is equal to a prime t over a t. Okay, then this is actually, so this is a trick. You can see this is the derivative of natural logarithm.
log.
Yeah. Mathematician write log, but always log means natural logarithm in this lecture. And yeah, so using this, you can solve this, the differential equation. So 0 to t delta r dr, we integrate it, then this is the log of a of t and plug in t and 0. So this is equal to log of a of t. Log of a of 0 is equal to 0 because a of 0 is equal to 1. So this is equal to 1. So this becomes 0. Okay. So this means that the a of t is equal to exponential 0 to t delta r dr. Okay. So in this case, we can, yeah. So we can calculate a of t from delta t. And the more useful formula may be a of t 2 over a of t1. So sometimes we compare the amount at time t1 and t2. So this is a little more general. And to just apply this formula twice, then a of t2 is 0 to t2 delta r dr. And a of t1 is in the same way, exponential 0 to t1 delta r dr. But you can see that this is, exponential. So the difference between these two, 0 to t2 minus 0 to t1. So that becomes exponential of integral t1 to t2 delta r dr. So just you can change the range for integral from t1 to t2. Then that becomes the a of t2 over a of t1. So it may be more useful formula to apply. And the example using this. So suppose that the delta t is equal to 0.03 plus 0.01 t. So this is a typical interest rate path. So the interest rate increases by 1% a year. So this year, it's expected that we have 4 interest rate hike. Actually, in the last lecture that I said the 3 times interest rate hike, 0.7%. But in this week, the market consensus has been changed, and we may have the 1% interest increase this year. Okay, so delta t is equal to 3% plus 1% increase each year is the realistic scenario. And okay, so now that we want to calculate this, calculate the amount of interest earned during t is equal to 1 and t is equal to 3. So between t is equal to 1 and t is equal to 3, when a of 1 is equal to $1,000. So you can see that the $1,000 and the interest rate at t is equal to 1 is, the force of interest is 4% here, and t is equal to 3, 6%. So on average, maybe 5%. So 5% for 2 years from t is equal to 1 to 3. So approximately probably 1,100. That is my best guess. Okay, so interest is about $100. So that is my guess. Okay, so the strategy. So at first, okay, so finally we want to get the capital A3 minus capital A1, but basically we have to calculate A3. And capital A3 is equal to capital A1 times A3 over A1, right? Maybe we can say capital A3 over capital A1, but just that we have the constant times. The capital A is constant times lowercase a. So that we can do this. So basically we need this one, right? But this one can be obtained by the formula in the previous page. So that's the way to go. So basically at first we can calculate the step 1, the A3 over A1. Then A3 over A1 is exponential of 1 to 3 delta r dr. So this is equal to exponential 1 to 3 0.03 plus 0.01 r dr. So this is exponential of, okay, so this is just polynomial. So integrate then 0.03 r plus the 0.005 r squared. Then plug in 3 and 1. Then this is exponential of plug in 3, then the 0.09 and the 0.045, right? So this is 0.135. Then plug in 1, then 0.035. So negative 0.035. So this is exponential of 0.1. So this is equal to 1.10517. Okay, so then step 2, we can calculate capital A of 3. This is A of 1 times A of 3 over A of 1. So 1.10517 times, sorry, the other way around. So capital A1 is 1000. So this is equal to 1105.17. So A3 minus A1, step 3. This is this one minus 1000. So 1105.17 minus 1000. So 105.17. So this is the accumulated interest. So yeah, on average 5% interest. So 100 is pretty good guess for the answer, but yeah, it's slightly larger in reality. Yeah, so today's last quiz, the Q1-12-7, is similar to this question. We have different the delta t, but the idea is similar. Okay, so do you have any questions?
Hey, Martin Luther King Jr. Day.
Sorry?
Happy Martin Luther King Jr. Day. That's gonna be coming up Monday.
Oh, okay, yeah.
And also, are we gonna have more bonus points like this opportunities
Sorry?
in future? Are we gonna have more bonus point opportunities in the future lectures?
Yep.
Okay, thank you.
Yeah, and the quizzes are due Sunday, I think Sunday, yeah, Sunday. And the solutions are posted on Tuesday, but yeah, if you need the solutions to the quizzes before that, then you can email me, then I can email you solutions. You know, assuming that you have finished quizzes.
I just figured it out on my own.
Okay,
I didn't look at
yeah.
the solutions. I just figured it out on my own.
Yeah. Actually, the quizzes, the daily quizzes are not so difficult. So I think that probably the problem and the answer is fine. But if you need, yeah. Okay. So see you next Wednesday, and we have a quiz on Wednesday.
Professor, when will you assign the homework?
All right. I cannot really hear clearly.
When will you assign the homework? I know you mentioned you were going to assign.
Oh, homework. I will post today.
Okay.
Then maybe, yeah, in 1 hour. Yeah.
Thank you.
Sure. Okay. So see you next Wednesday if you don't have any question or comments.